Game Theory Fundamentals, Episode 2, Types of Games. In the previous episode, we introduced the basic concepts and terminology of game theory and analyzed the famous prisoner's dilemma. In this episode, we will explore different types of games that game theorists use to model various situations and scenarios, such as cooperative and non-cooperative games, symmetric and asymmetric games, zero-sum and non-zero-sum games, simultaneous and sequential games, perfect and imperfect information games. One way to classify games is by whether they are cooperative or non-cooperative. These games differ in the degree of communication and coordination among the players. In cooperative games, players can form coalitions and negotiate agreements to achieve a common goal. In non-cooperative games, players act independently and cannot make binding contracts. An example of a non-cooperative game is the prisoner's dilemma, in which two suspects are arrested and interrogated separately by the police. Each suspect can either confess or remain silent. If they choose to stay silent, they both get a light sentence. If they defect and confess, they both get a harsh sentence. If one confesses and the other stays silent, the confessor goes free and the silent one gets the worst sentence. After analyzing it in our first video, the solution to this game is the Nash equilibrium, in which no player has an incentive to deviate from, given the other player's strategy. In this game, the Nash equilibrium is for both suspects to confess, with both getting 5-year sentences. However, if the players were allowed to cooperate, they could agree to stay silent and get 1 year in jail each. This would be an example of a cooperative game, where the players can talk to each other and make agreements. Another way to classify games is by whether they are symmetric or asymmetric. A symmetric game is one in which the players are identical in terms of their strategies and payoffs. An asymmetric game is one in which the players are different in some way, such as having different strategies, payoffs, information, or roles. An example of a symmetric game is rock, paper, scissors, in which two players simultaneously choose one of 3 options: rock, paper, or scissors. The outcome is determined by the following rules: rock beats scissors, scissors beats paper, and paper beats rock. The payoffs are the same for both players, +1 for winning, -1 for losing, and 0 for tying. Rock, paper, scissors is considered a symmetric game because the strategies available to each player are identical, and the rules apply uniformly to all participants. In this simple hand game, each option, rock, paper, and scissors, has an equal chance of winning, making the game symmetric. An example of an asymmetric game is the ultimatum game, in which one player, called the proposer, has to offer a division of a fixed amount of money to another player, called the responder. The responder can either accept or reject the offer. If the responder accepts, the money is split according to the offer. If the responder rejects, both players get nothing. The payoffs are different for the two players. The proposer's payoff is the amount of money he or she keeps, and the responder's payoff is the amount of money he or she receives. Then we have zero-sum and non-zero-sum games. A zero-sum game is one in which the sum of the payoffs of all players is 0 for every possible outcome. In other words, one player's gain is another player's loss. While in non-zero-sum games the players can have mutual gains or losses. Rock, paper, scissors is a zero-sum game because the total payoff for both players is always 0. This means that whatever one player gains, the other player loses. For example, if rock beats scissors, the winner gets +1 and the loser gets -1, so the sum is 0. The same applies for any other outcome of the game. In a non-zero-sum game, the total payoff can be positive or negative, depending on the player's strategies. For example, in the prisoner's dilemma, the total payoffs aren't 0, but negative. However, the extent of negativity can vary depending on the chosen strategy. Simultaneous and sequential games. A simultaneous game is a game where the players choose their actions at the same time, without knowing what the other players are doing. An example of a simultaneous game is rock, paper, scissors. A reason why simultaneous games are interesting is that they often involve uncertainty and incomplete information, which makes the players' decisions more complex and challenging. A sequential game is a game where the players choose their actions one after another, and each player knows the previous actions of the other players. An example of a sequential game is chess, where each player moves their pieces in turn and can see the whole board. A reason why sequential games are important is that they often involve planning and foresight, which makes the players' strategies more dynamic and sophisticated. Perfect information and imperfect information games. To determine that a game is a perfect information game, certain requirements must be met. Sequential moves, players take turns making decisions, and each player observes the actions of all previous players before making their move. No hidden information, all players have complete knowledge of the game's state, including past actions, current positions, and available options. Transparent rules, the rules governing the game are fully known and understood by all players, leaving no room for ambiguity or uncertainty. Deterministic outcomes, the consequences of each action are predetermined and do not involve chance or random elements. These requirements ensure that players have equal access to information, allowing for strategic planning, rational decision-making, and the absence of luck or hidden knowledge. Perfect information games are often represented using extensive form game trees, where each node represents a decision point and the edges denote possible actions. We will cover this in our next video. An example of a perfect information game is chess, as each player can see all the pieces on the board at all times. The reason why chess is a perfect information game is that there is no hidden information or chance involved in the game. Every move is observable and deterministic, and the outcome depends only on the player's strategies. An imperfect information game is a game where each player does not know some aspects of the game, such as the actions, preferences, or payoffs of the other players. A simple example of an imperfect information game is poker, where each player cannot see the cards in the other player's hands. A reason why imperfect information games are interesting is that they often involve uncertainty and incomplete information, which makes the players' decisions more complex and challenging. So we have learned about some of the different types of games that game theorists use to model various situations and scenarios. There are a lot more of details that can be covered in depth for these types. Let me know if you are interested in them. In our next video, we'll dive deeper into the fascinating world of strategic and extensive form games. Don't forget to like this video if you found it helpful, and share it with your friends who are eager to learn about strategies. Stay tuned, and thanks for watching.